Welcome back. In our last video, we looked at limiting reagents and theoretical yield. We calculated which of the reactants would be our limiting reagent and how that would lead to a certain amount being produced, which was our theoretical yield. One of the other terms we used last time was excess reagent, and that was the thing that was not the limiting reagent. In this one, we're going to not only be able to identify it, but now we're going to calculate how much excess we have of a certain substance. So just to remind us of a few things, we're going to look at our terms. Our excess reagent is the thing that has not been completely used up, while the limiting reagent is completely used up. The example we used in our last video was making hot dogs, and we had limited to 8 hot dogs because the buns were limiting, and we had excess of weenies, which meant that our weenies were the excess reactant. In this video, we're going to figure out how to calculate how many leftovers we have. In the case of the hot dogs, it was pretty easy because we could just look at how many weenies are left. In the case of the chemical elements, it's a little more complex, but not a whole lot. Should be something that you'll hopefully grab onto pretty quickly. Here are our steps that we're going to look at. First thing we would do is find the limiting reagent. Then we would convert the limiting reagent to the excess reagent. Finally, we would subtract the amount of excess reagent from the given amount. So there's a certain amount that we started with, but we're not going to use it all. So once we find out how much we do use, we'll subtract it. Now let's look at what that will look like in an example problem. Our example problem: if 15 grams of aluminum sulfide and 10 grams of water react until the limiting reagent is used up, how much excess reagent remains after the reaction is complete? So our aluminum sulfide there is the first, and then we have the water, which is our second. So those are the two reactants. One of them is limiting. In this video, we're not going to go through and calculate the limiting reagent, but if you need a reminder on how to do that, you can check in with the last video that dealt with limiting reagents and theoretical yield. For this case, I'm going to go ahead and let you know that the limiting reagent is water, which means we are going to skip past step 1. If we look at our two reactants, we have water and aluminum sulfide. So if the limiting reagent is water, that means our excess reagent is going to be the aluminum sulfide. So our second step is going to be that we're going to convert from the water, since it's the thing that limits the reaction. We know we're going to use all of it up, and we're going to see how much aluminum sulfide would need to be used if we started with the 10 grams of water that is given to us in the problem. So we do this just like we've been doing with the other stoichiometry that we've looked when we did the mass-to-mass conversions. We start by using the molar mass ratio so that we convert out of grams and into moles. Then we use our mole-to-mole ratio that we get from looking at the coefficients that are in the chemical equation. That allows us to switch from moles of water to moles of aluminum sulfide. And finally, we use the molar mass ratio to get rid of moles of aluminum sulfide and convert it into grams. And that will give us a value of 7.95 grams of aluminum sulfide. That means that every time we use 10 grams of water, we will also use 7.95 grams of aluminum sulfide. And that completes step 2, and we'll move on to the final step, finding the difference between those values. We know that in the problem, we're given a total of 15 grams of aluminum sulfide, but from our calculations, we know that we're only going to use 7.95 of them. So we subtract 7.95 from 15 grams and find out that there's a total of 7.05 grams of aluminum sulfide left over. So that is the amount of the excess reagent. And that concludes what we needed to do in this. We've finished step 3 and we found our answer. This means that at the end of this reaction, we would have 7.05 grams of aluminum sulfide left over that are not used up during the experiment. The last video in this series is going to be one that looks at percent yield, that looks at how much is recovered in an actual experiment rather than just looking at what should happen based on the calculations that we can do. So I hope you'll join me for the last video in this series, and I will see you soon. Have a great day.